Hello everyone, welcome back. I'm reading from my new book, Intense Design. I hope you enjoy it. This is part of the applications section, so the book's divided into kind of two parts. It's actually three, but first two parts are kind of academic. They're looking at skunkworks and creative organizations, real important and helpful stuff, things that I hope will stand the test of time because they go back to the Cold War era, looking at skunkworks during the Cold Era. So I thought that was really an interesting benchmark. We look at benchmarking, but it's fun to do one with a real historical foundation. But now I want to talk a little bit about things that are in the applications section, which are real applied elements. So I'm going to read chapter 16, design considerations with annotations on them. So this is a big issue for me too, because when you look at professional design, you're looking at things that people might not look at otherwise. You're really asking some questions and trying to resolve things before designs get really fleshed out. So let me read this and annotate it as necessary. So consider how your design will be used and misused. You need to identify these problems before they arise. Then you either solve them or warn the user. This investigation needs to go far further than looking for pinch points, sharp edges, and other obvious safety issues. Failure mode and effect analysis, FMEA, can be a beneficial adjunct to this process. And below our listing of categories to consider, these topics will vary widely depending on your market. So design consideration topics, the first one is safety, first do no harm. I have a whole section on ethics in this book that I won't read in here, but I hope you find that helpful. And it has a couple stories in it rather than just kind of a listing. And it's not academic too, because the real world is different than what a lot of universities will present in ethical reviews, because there's work at will states and a lot of things that come into play. So anyway, safety, the first design consideration. Scope of the application, who will use it and for what purpose. Regulations, what regulations govern your design. The price, that's important. Durability, how long do you expect it to last? And that can be important on the economic side too. They'll ask often the designer, the design life for something, and you need a number because it's important to justify a project. Ergonomics, how well does it fit your body and the movement of the body. Sustainability, where do the raw materials come from and how is the product disposed of when it's finished, its service life. Can it be disassembled easily and recycled? Material culture and brand management. And then human misuse, which is a real big topic. It's really what I want to talk about, and I've got sort of the checklist that helps with this. So how can people use or misuse your object? That's kind of the tough part. How they use it is hopefully not a surprise because you designed it to be used in a certain way. But misuse is a big issue. So let's look at some of these listings, and I have kind of this checklist here at the end that might help you. But anyway, vandalism. Start with that. And I'm not going to read this verbatim, but what will vandals do to your design? They can do obvious things to it, but they can also do things to it that you might not recognize. And of course, this all is under the context of safety. So you consider insidious forms of vandalism. What will children do to your design? Because they love to explore. And what are they going to do with their design? It's a whole specialty. Infants, they put everything in their mouths. What does that mean? Also, you know, their body proportions are different than what we normally anticipate. So that's a whole big issue. Inexperienced users, you know, nobody reads the manual. They just grab things and try to work with them. So you've got different types of users depending on what you're dealing with. In some cases, you're dealing with the consumer market. Sometimes you're dealing with engineers and other professionals in which the anticipated expertise is at a higher level, and you do different things in that case. But what would an inexperienced user do? Because they're going to twist and turn things. They're going to just experiment with stuff to get your design to work. You should expect that. You might even tap on it a little bit. They'll see they'll see hinges and things that they think should move, and they'll try to twist things. How will your design be modified or hacked? That happens. What are people going to do to it? What will irrational users do? And by irrational, I basically mean drunk, inebriated in some way. What are they going to do with your design? And then emergencies. So in an emergency, might somebody use your design to break glass or pry something open or whatnot? And again, that's not your problem per se, but if you've designed a screwdriver, you can expect that it's going to be used to wedge open a can of paint and other things. You can get more extreme than that. But those are some of the things to think about. Environmental considerations. So that first part was really what humans can do to misuse your product. So you just want to think about it and do it with some other people too, because you'll come up with some neat ideas and you'll be humbled. If you do it by yourself, you're going to miss something. I always do. Environmental conditions, temperature and humidity. So temperature ranges, as you know probably, when you store something in a sealed container, like in a container ship, it gets very hot or very cold. So if you just, a ball, bouncy ball for a child does not get stored in a warm house. It gets stored in some warehouse. It gets cold, or on a ship, or on a train, or something like that. So think of the range of temperatures and humidities. Think about sunlight. What will sunlight do to your design? Again, if you don't mind that it gets faded, that UV light fades it, then you don't have to worry about it, but you want to recognize that. And the same with infrared heating of your object. If something is going to get real hot and burn someone when they touch it, that may be okay, but you should just know that it could happen. What will ice do? Ice expands volumetrically. Water expands volumetrically as it freezes, and that's going to pry things open. Is that a problem for you? Snow. Snow is heavy. It settles on horizontal surfaces and vertical surfaces sometimes too, and like with ice. So what will that do? It increases windage and weight and all kinds of things. What will the wind do to your design? This might not apply, but it could. Including vortex shedding, like you see the Tacoma Narrows Bridge and signage and so on. You can get some interesting aerodynamic effects with the wind that will surprise you. Lightning. What will lightning do if it hits your object? It won't hit your object, you say. Well, it might. You'll be surprised, and I've dealt with some things where lightning is an issue that we didn't think it would be originally. Hail. What will hail do? Do you care? If hail will destroy it, that's fine, just so you know that we get hail sometimes in parts of the world. What will dust and sand do to your design? That's important. Insects, real big issue. All kinds of bugs are going to make homes in your design, and what will that do? Including spider webs and caterpillar webs and silks and all that sort of thing. What will it do? It's going to plug drain holes. It's going to do all kinds of stuff. They'll do bad things, and when they die, their carcasses fall and accumulate, and what does that mean in your design? Temperature swings. In the desert, you get these big temperature swings because the wet bulb temperatures are so low. So big temperature swings mean big thermal expansion or thermally induced stresses. Body heat, when you hold something, it gets hot and sweaty. What does that mean? Pressure differences. The wind can produce pressure differences, but you get barometric changes in the air and other things. In the high altitudes, you get long days and long nights. So, above the Arctic Circle or Antarctic Circle, you get 24 hours of daylight or night. And of course, at the extreme latitudes, you get very long days and nights too. So if you have a photovoltaic, that's not going to work in southern Chile in their winter, or in Svalbard in the northern hemisphere winter. Monsoon rains. Some areas get long enduring rainfall with no drying periods. Some places get very strong rain too. And then on the strength side, you have, or just sort of the outside of environmental concerns, you have material compatibility, impact, fatigue, vibration, buckling, corrosion, and thermal expansion. And I kind of call those weird loads because people often don't think about that sort of thing. So you want to think about that sort of thing in your design and reflect on all the misuses your design can have, and maybe design ways around them, but you want to at least recognize them. Slapping a sticker onto your design is one way to handle this, but sometimes there's more clever ways. Thank you.